Hey everyone, welcome to our next video. This is 5.4, which is trigonometric functions defined on the unit circle. So 5.4, trigonometric functions defined on the unit circle. We've already worked with the unit circle a little bit at this time in our previous videos, but now we're going to kind of tie it all together. So the unit circle is a circle with radius 1. And so if I draw our unit circle, sorry about that. If I draw our unit circle, sorry, it's like crashing. Okay, try again. All right. If we have a radius 1, that means I would go through the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. I'll also remind you this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. In radians, 0 or 2 pi, this would be pi over 2, this would be pi, this would be 3 pi over 2. The other common angles we've talked about up to this point is the angle of 30 degrees, 45 degrees, and also 60 degrees. In radians, that is pi over 6, pi over 4, and pi over 3. The unit circle is a circle with radius 1, so imagine that there's a circle wrapped around all of this, and imagine it's actually a circle and not my terrible drawing. Every point on the circle is a cosine of an angle, comma, sine of an angle point. How do we know this? So cosine, remember, is x over r. Sine is y over r. Well, if my r value is 1, then on the unit circle, cosine is x and sine would be y. So every point that is on our unit circle is a cosine, comma, sine point. So here's what that tells me. At 0 degrees, if I do cosine of 0 degrees, that gives me 1. If I do sine of 0 degrees, that gives me 0. Let's say I go over to 90 degrees. So cosine of 90 degrees is 0. Sine of 90 degrees would be 1. And we could do this for every single point on the unit circle. So at 30 degrees, I would have the point cosine of 30 degrees, comma, sine of 30 degrees. Now cosine of 30 degrees is square root 3 over 2. Sine of 30 degrees is 1 over 2. At 45 degrees, cosine of 45 degrees is square root 2 over 2. Sine of 45 degrees is square root 2 over 2. 60 degrees. Cosine of 60 degrees is a half. Sine is square root 3 over 2. So some of you in your past, you may have had to memorize the entire unit circle. I don't think it's necessary to memorize the entire thing or really even use it in that way. I think it's good to know. I use the unit circle whenever I'm looking for like quadrantal angles. So let's say a question just asked me, okay, what is sine of 180 degrees? Well, I would look at 180 degrees. Sine is the y value, so I would immediately be able to say that it's 0. Now, when it comes to the non-quadrantal, so 30, 45, and 60 degrees, I don't really recommend like memorizing this per se, like memorizing these points necessarily. I use the table for the 30, 45, and 60, the table that I showed you in the last two sections. We used it. So if you haven't seen the table, you might want to go back and watch those sections. And then if I want any points on anywhere else on the circle, so if I want, say, something in quadrant 2, if it has a reference of 60 degrees, so that would be 120 degrees, has a reference of 60 in quadrant 2. That also is the point 1 over 2 comma square root 3 over 2. Just like the 60-degree angle in quadrant 1. So the 60-degree angle in quadrant 2 is actually 120 because it'd be 180 minus 60. So it's the same point. The only thing that would change is now the x values are negative. In quadrant 3, there's an angle with a reference of 60. It also goes through the point 1 over 2 comma square root 3 over 2. Again, the only thing that changes is that they're both negative. The angle with a reference of 60 in quadrant 3 would be 180 plus 60, so that's 240 degrees. In quadrant 4, the angle with a reference of 60 goes through the point 1 over 2 comma square root 3 over 2. The only thing that's negative is the y value now. And this angle would be 360 minus 60, so that's 300 degrees. I could draw out this whole thing for you, but I'm just going to go ahead and look at a picture of it. I think it'd be a little bit easier. This one's kind of nice. Can I make it bigger than that? It's just zooming in on the side. There we go. So if you look at this one, in quadrant 1, you've got the 30 degrees, 45 degrees, 60 degrees, and they have those points written out for you. If you look at every quadrant, you can see all of your references. So for instance, I'm looking in quadrant 2. 120 has a reference of 60. So it goes through the same points that 60 goes through. So if you think about the last video we did, 5.3, I talked about how you can just look at the table and sine of 120 is the same as sine of 60. Cosine of 120 is the same as cosine of 60. The only thing that could change is whether it's positive or negative since you're in quadrant 2. If you look at quadrant 3, the points repeat themselves again. Quadrant 4, the points repeat themselves again. You are welcome to memorize the entire unit circle if you would like to. However, I find that most students forget about it a little too quickly, and we're going to be using this the entire quarter. So you really want whatever is going to help you remember it like long term. So I like to use reference angles and I like to use the table to do the non-quadrantals. I do think about the unit circle when it comes to the quadrantal angles though. So I'm just going to come back to our notes now. So I just want to show you the unit circle a bit. And then we only have like one different type of question that shows up in the homework for this section. So I'll just go ahead and do that one. This isn't a very long section. It'll be example 1, and it says given f of x equals secant x, find f of 3 pi over 4. So this is what we call function notation. It's just saying that you want to plug 3 pi over 4 in as your x value. So if I have f of 3 pi over 4, I would plug 3 pi over 4 into secant. And so we need to know what quadrant 3 pi over 4 is in. So this would be pi, or it can be written as 4 pi over 4. So 3 pi over 4 would come right before that. My reference is pi over 4, or 45 degrees. So if you go back and look at your table, just a reminder, when I talk about the table, I'm talking about this table that I showed in 5.2. So I'd say, okay, 3 pi over 4, it has a reference of pi over 4, which means it acts exactly like 45 degrees. Secant is the reciprocal of cosine. So if cosine of 3 pi over 4 would be square root 2 over 2, and we're in quadrant 2, so only sine is positive in quadrant 2, so cosine would have to be negative then. So the secant would just be the flip of cosine, the reciprocal of it. So that would be negative 2 over root 2, which simplifies to negative root 2 if you rationalize. So that would be the answer to this problem. So this really isn't different from the last section from 5.3. The only thing that has changed is it's a little bit different of a notation. So on your test with me, usually I'll ask you, I can ask you definitely the function notation. Usually I just say stuff that says like find exact value. And I can just ask a bunch of different things like cosine, pi over 6, b, cotangent, pi. Let's do c, tangent, 240 degrees. Any of these would be things that you could see on our test. And so I'll do these quickly for us. Cosine pi over 6, that's in quadrant 1. Pi over 6 is the same as 30 degrees. Cosine of 30 degrees, if I look at my table, square root 3 over 2. Cotangent of pi, so pi is going to be over here. It goes through the point, negative 1, 0. Remember that cotangent is the x over the y, or the adjacent over the opposite. So x would be negative 1 over 0. So this is undefined. Tangent 240, so 240 is in quadrant 3. How far is it from the x-axis? It would be 60 degrees. So tangent 240 is the same as tangent of 60. Remember, tangent is the y over the x. So y over x. This would be square root 3. And tangent is positive in quadrant 3. And to do the positive and negative, I'm using all students take courses. So A for all, S for sine, T for tangent, C for cosine. So tangent is positive in quadrant 3, so this one would be positive. So that's just a few more examples of kind of what we did in our last section. So again, exact value is going to be super important for us throughout the quarter. We're going to use it in just about every single section. So being able to know sine, cosine, tangent of all the angles in the unit circle. Now, if you want to memorize the unit circle, that's fine. That's up to you if you want to do that. I think you basically just need to know the first quadrant, which is what's in the table, and then being able to use references to apply that to all the other quadrants is my preference. But whatever is easier for you is what you should do. Alrighty, so that's it for our section 5.4. So I will see y'all in the next section. Have a good day. Bye-bye.